Hello. I've shown you how to calculate the second derivative for a couple of functions, but they didn't represent anything. However, we know from the lesson that we have these three quantities that I keep reminding you about: displacement, velocity, and acceleration, as you can see in the title, that are very closely related to one another. So let's actually involve these three quantities in the following example, in which we're going to determine the velocity and acceleration, let's say after 4 seconds, for the position function s of t given by t squared times t minus 1 times 1 plus t. So I have this example in which the position function is given the displacement, right? And what we need to determine is the velocity and acceleration. We already know from the lesson what velocity represents is nothing else than the first derivative for the position function, and acceleration is the second derivative of the position function. Or, if you wish, you can consider it the first derivative of the velocity. So, that being known, this problem becomes very simple. We know the relation between these three vectors. Let's actually go ahead and calculate the first derivative for this position function s of t. As I told you before, every time you try to derivate a function, have a look first. What do you have in there? And what I notice is a product of three expressions. Let's consider t squared to be f, t minus 1 being g, and 1 plus t being h. Three separate functions. And as I told you in the previous chapter, in one of the examples, a product of three functions is very easily approached using the following formula. The derivative of f times g times h is going to be f prime gh plus f g prime h plus f g h prime. And that's what I'm going to apply to determine the s prime of t. And I'm going to derivate it from the beginning because they are simple expressions, right? So the derivative of t squared is going to be 2t times the two other expressions, t minus 1 times 1 plus t remain unchanged, plus t squared times the derivative of t minus 1, which is 1, so I'm not going to write anything, times 1 plus t, plus t squared times t minus 1 times derivative of 1 plus t, which is 1 again. So I'm not going to write anything there anymore. So this is basically the result, but we want to simplify a little bit more before we derivate it once again to bring it to the simplest form. And what I notice is that this t minus 1 times 1 plus t, or t plus 1, is going to be t squared minus 1 squared, right? Or 1. So I can continue to say it's equal to 2t times t squared minus 1 plus, let's expand those parentheses, so it's going to be t squared plus t at power 3 plus t at power 3 minus t squared. Right away I see that t squared and minus t squared are going to be 0. I also have a couple of like terms, like t at power 3 and t at power 3. And I'm going to expand that parenthesis in the next step to t at power 3 minus 2t plus 2t at power 3. And I'm going to add these like terms again to end up with 4t at power 3 minus 2t. Or let's factor 2t times 2t squared minus 1. And what we determined here is the first derivative of the position function or the velocity. So we have already determined the first thing. Now let's calculate the second derivative for this position function, which is after all nothing else than the derivative of s of t. Let's calculate because the expression is so much easier to approach now. We have derivative of that expression for t at power 3 minus 2t, the expression we just found earlier. So it's going to be 4 times 3, which is 12, t at power 3 minus 1 t squared, minus the derivative of 2t is 2. And here again we can factor out 2 times 6t squared minus 1. And we know that the second derivative is nothing else than the acceleration, a of t, right? So we determine both velocity and acceleration. The only thing that we have to determine now is to determine this velocity and acceleration after 4 seconds. We have the expressions for both velocity and acceleration in regards to time. All we have to do is replace t with this value of 4. and evaluate those expressions. So, let's start with the velocity and say if velocity v of t equals to 2t times 2t squared minus 1, the expression we just found, then the velocity after 4 seconds, so v of 4 in other words, is going to be, just replace everywhere we have t in this expression with the value of 4. So it's going to be 2 times 4 times 2 times 4 squared minus 1, and this is 8 times 31 or 248. So we have a first result, and the second, if we know the expression for the acceleration in regards to time, a of t, we determine it to be 2 times 6 t squared minus 1, then a of 4, the acceleration after 4 seconds, is going to be replacing t in the general expression of the acceleration with the value of 4. We're going to have 2 times 6 times 4 to the power 2 minus 1. And this is nothing else than 2 times, and parentheses there we have 95, and all this is equal to 190. And let's put some measuring units. Velocity is going to be meters per second, acceleration meter per second square. And this is another example that you can see how the connection between displacement, velocity and acceleration comes in very handy to find the results very easily by just finding the first and the second derivative for the displacement function. Hopefully you found this example useful. Thanks for watching.